Lesson 8.11. This lesson was about inequalities with two variables, and the goal was to use the graphing method to solve or estimate the solutions of complex equations and inequalities. So let's take a look at problem number 6a. On the same coordinate plane, graph the two lines y equals x plus 1 and y equals negative x plus 11. So if you have a graphing calculator, that's very convenient, but at the same time you can find the 2 points, and since this is linear equation, so let me take the first equation, which is y equals x plus 1. So if x is 0, then y will be 0 plus 1, so that's 1. And if x is, for example, 2, then y will be 2 plus 1, so that's 3. So let me just, all we have to do is just plot those points. 0, 1 is right there. And 2, 3 will be 1, 2, and 1, 2, 3. And if you connect that, that's the y equals x plus 1. And another line is y equals negative 2x plus 11. And if x is 0, then y will be 11. If x is 2, then y will be, that will be negative 4, so that's going to be 7. So let me do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's my first point, and the second point will be 2 and 7. So that's 3, 4, 5, 6, 7 right there. So that's gonna go like that. Then you see the intersection is right there. And B says find the value of x such that x plus 1 equals negative 2x plus 11. So what's the point here? That's what basically asking for B. C, find 2 points x, y such that x is greater than x plus 1 and lower than that. So that means the greater than this line, so it's this part, and also the lower than this line, which is this part. So it will be somewhere in there. So if you take any points in this area, then that will be the answer for that. And D, you do the opposite. So you're gonna have to find the greater and greater. So it has to be the greater than this line will be here, and the greater than this line will be here. So if you take some lines from here, and so on and so forth. Problem number 8: sketch the solution set of these inequalities. So also you can kind of pretend that 2 times parentheses x minus 3 parentheses close plus 3y equals 12. So 2x minus 6 plus 3y equals 12. You can draw a line by just kind of pretending that that's equal sign. So we have 2x plus 3y equals 18 by adding 6 to both sides. And if x is 0, then y will be this part will be 0. So 3 times y is 18. So it's got to be 6. If y is 0, then that's going to be 2x plus 0 plus 18. So if y is 0, then x has to be 9. So you plot these 2 points, and on here, right here, and then you can draw a line. The line will be, I don't know, it's 0, 6, 0, 6, and no, 0, 6 right here. Right here, and 9, 0 will be 3, 3 somewhere over here. So those are going to be the line right there. You use dotted line because it's actually the original problem is less than, but you don't have equal sign, so you use dotted line. And that's less than that, so it's going to be this area. Okay? And you do the same thing for different equation here, and that's going to be the end of part A. And then use that graph to answer the rest of the problem.
standardized test prep. Without point, which point is not in the intersection of the graphs of y equals x squared plus 5x plus 6 and x is less than 4, so y is less than 4. So we can plug in some numbers to see if it works. So let me just do a. So y is 3 here. Is it greater than negative 4 squared plus 5 times negative 4 plus 6? Is it? So it's 3 is greater than 16 minus 20 plus 6, which is 2. So 3 is greater than 2. So that's good, but we have another one. Is y less than or equal to 4? In this case, y is 3, and 3 is less than or equal to 4, so that's good. So A is good. How about B? How about C? You plug in different numbers to see if there is some contradiction, then that's going to be the answer. And problem number 10, graph y is greater than absolute value of x. Where is the shaded area relative to the graph of y is greater than y is absolute value of x? So if you remember that we did it probably term 2. So if x is negative 2, absolute value of x will be 2, and negative 1 it's 1, and 0 and 0, and 1 1, and 2 2. So it's going to be like a V shape if you remember. So plug these points in here, and that's going to be an answer part A. Part B, use the graph of y equals x to the third minus x to draw a graph of y is greater or equal to x to the third minus x. Well, obviously, where would be y would be greater than that line, so that's going to be this half of it. You see this line, and if you take the bigger part of it, then y is going to be always greater than the line. So, and see if an inequality has the form of y is greater than f of x. Do you shade a bubble below the graph of that equation y equals f of x and explain? Well, this is not. This is just basically what I did. This is basically. So that's it.